We are going to see the first exercise that is called as the MetaMask. We are going to see the installation of MetaMask and how to do the transactions using the MetaMask, right? So MetaMask is a Ethereum wallet. It is a browser-based wallet, and it is the most popular wallet in the Ethereum blockchain. So this is a small Chrome extension which can be added easily to the Chrome browser. So just type MetaMask in the Google browser and you will get metamask.io, this website. So just click this website and it will ask you to download the MetaMask. So you have to just download this MetaMask and add it to the Chrome. And during the installation, it will ask you for a password. So please do remember the password so that it is always used to log in. So once a MetaMask is downloaded and installed, then on the right corner of your browser, you can see a small fox symbol which shows the MetaMask. So we have to just click that so that your MetaMask opens. So using the MetaMask wallet, we can store our ethers. So this shows your MetaMask wallet. Now, this is the Rockstone test network. So once you click this, it will show you the different types of test networks here. So the main Ethereum network is a default one, but actually we are not going to use it. Only the test network we are going to do. So Robston, Coven, Rinkiby, Corelli, localhost, and other localhost custom nodes also you can create it. So this is the different types of networks this particular MetaMask wallet allows. And here on the right side, you have a small circle which indicates that different types of accounts. So I have a lot of accounts here. So account 1 has 3.99 ethers, account 2 has 2.99 ethers, and account 3 has 0 ethers. So likewise, you can create any number of accounts here, and we can create some more accounts here. And this is for importing the accounts. When you want to import to some other wallet, then you can do it here. So this is about the different accounts. And below every account, you can see a small number here. So this is the address for every account, which is written in the hexadecimal. And then this shows how much is your balance. And there are two options here, deposit and send. And down it shows the history of the transactions that you have done. So when I deployed a contract, I have used some ethers, and I can transact to my friends, or I can transact within my accounts also. So likewise, many transactions can be done. So all those transactions will be visible here. And there are two buttons here, deposit and send. So deposit is to deposit the ethers into your account. Either you can directly deposit if you have already have ethers. Otherwise, we can get the test ethers from the test faucet. So once you click this, then it will direct you to the faucet where you will get free ethers. So this is for the free ethers, and you can also send the ethers to your accounts or to your friends. So when you click the send, it will show you transfer between my accounts because I have nearly four accounts, so I can transfer any ethers from account to account. Or if you know the address of your friend, then you can type the address and then do the transfer also. So this is how the MetaMask wallet is used to store the ethers in your wallet and hence used for the transaction also, right? So this is for the deposit and the send. And next comes the how we can see the transactions. Okay, so click on the menu, then you have account one. When you see here, there is a details button. So when you click details button, it will show you the QR kind of it. So even the wallet like Paytm, you can do the transfer of ethers even if you scan this QR code. And this is the address of your account. And view on Etherscan and export private key. View on Etherscan is a Etherscan is an Ethereum Explorer where it will show you all the history of your transactions. And export private key means whenever you want to do some applications, when you want to run your applications in Ethereum blockchain, then if you want to unlock your account, then you need the private key. So during that situation, you will make use of the private key. So this is how the MetaMask ID is done, and all the wallets can have the test ethers. So only using these test ethers, we are going to deploy the contracts further in the blockchain structure. So the next one is how a blockchain will look like. So we are going to show a small demo of the blockchain. So you can just type a blockchain demo in the Google browser. So the first link that comes is andersbrownworth.com blockchain hash. So this website is going to tell you how this uh, blockchain is going to work, a demo of it. So the here you have different tabs here. So you have hash, block, blockchain, then distributed tokens and Coinbase. Right. The first one is the hash. We'll see what is called as hash. So the blockchain is said to be more secure because it uses a hashing algorithm. It is a one-way hashing algorithm, and many hashing algorithms are there. One such hashing algorithm is SHA-256. So it's secured hashing algorithm. 256 bits is the length of its key. So for the empty data box, this is the hash value. So if when you type something here, then your hash value key changes. So for every message, a unique hash value will be generated. Then comes your block. So block as such, we know it will have a block number, and then it's a nonce value, it's one time value, and then you will have the data box and the hash which we have seen in the previous one. So here, as I said before, the color of the box is green. As soon as I change some data here, then the color of the box changes to pink. So it means that it can be a fraudulent action or it can be an update operation also. But whatever action must be there, it has to be validated. So this validation is done by a group of people called miners. So the miners will have a good computing power, and they'll be solving a computational puzzle, and they will get a hash value which looks like a similar the previous hash value. So when you want to turn this into a green color back, you have to just click on mine. This will take some 2-3 seconds. It depends on your computer speed. So this miner will mine a block as a reward, and he will validate all the transactions also. So he will be working out a puzzle, and he will be getting a hash value which looks like the previous hash value. So only when the miner validates a transaction, then the transaction is added in the blockchain. So this is how block will look like in a blockchain demo. So this mining might take some time. So next is your blockchain, where in blockchain you will have a different set of blocks. Okay, where one there can be 10 blocks or 20 blocks together, and all these blocks are connected via the hash value. So these hash value, see now it has turned into green color. So and it looked like the hash value previous to your hash value, right? So next comes your blockchain. So where it means the number of blocks are chained together using the hash value. So this is block number one, this is block number two, this is block number three. So each block will have a previous hash value and the hash value and its own hash value. So the first block has 00 as a previous hash value because it's the first block and the previous block is the genesis block. But whereas when you take the second block, okay, it has the previous hash value as the first block address, and it will have its own hash value also. Similarly, block 3, block 4, you can have any number of blocks. So when you try to change some data in the first block, then all the blocks turns out to be a pink color. So which means that if you try to change something in the any one of the block, then all the blocks which are previous to that will be showing an error. Its hash value will never match. So this is an indication of security vulnerability. So since hash value cannot be reworked, since you cannot get back the same hash value, such fraudulent transaction does not happen in the blockchain. Thus, blockchain is said to be more secure. So this is a small demo of the blockchain demo. So this is the end of your first exercise.